Before I start my talk, I thought I'd present to you a picture and a story, and perhaps that'll get you thinking about engineering in the real world and applications of it in everyday use. So I just want you all to think about what you see in front of you. So if you take a close look, I'm pretty sure you all know what it is. It's a basic necessity of life. It's a smartphone, and a smartphone that was only able to make, a mobile phone that was only able to make calls in the past can now do so much more. It's just like carrying a mini computer at the palm of your hands. And I don't know about you guys, but I definitely can't think of having to spend a whole day or even a couple of hours without a smartphone in my hand. And so the reason why I'm presenting you this picture is because a smartphone is a perfect example of engineering and how engineers come together to create something that we use in our everyday lives. So here's a testimonial about me. So who am I? So my name is Samaya Sultan, and I'm a recent graduate of Electronics Engineering from Macquarie University. I would first like to thank Widening Participation for arranging this amazing opportunity and sharing this with me. And I'm really excited to be talking to you all today. So not too long ago, I was sitting exactly where you are sitting today. I'm only a couple of years older than you, so that gives you an idea. And honestly speaking, I enjoyed and was fascinated by science subjects quite early on in life. And my, love for maths, physics and chemistry grew deeper when I started HSC. And so after I'd done my HSC and when I was looking at what should I be choosing in terms of career pathway, I was not 100% sure what I wanted to do. However, because of my attachment towards maths and physics and chemistry, what felt natural to me was either science or engineering. However, at that point, I actually didn't even know the difference between science and engineering, not too long ago. And so that's when I spoke to a careers advisor, and the careers advisor broke it down to me. And she said that science is basically looking at a problem and then going behind the reasons why the problem was caused and digging a bit deeper behind the scenes and why the problem was caused in the first place. Whereas engineering was looking at the problem and then having seen the problem, using existing technology and theory to solve the problem. And so growing up, I've always found that I enjoyed doing practical things rather than studying the theory behind it. And so engineer felt like the perfect match to me. As you can see in my little testimonial, you can also download this undergraduate course guide from the Macquarie University website where I share a little bit about my story. And as you can see, I've said I've enjoyed complex mathematics. And so when I was thinking about what I'd like to do at uni, I knew it had to be a practical and challenging degree. And engineering was the perfect match for me. So as I progressed through my engineering degree in the first couple of years, I started to appreciate more and more what engineering applications are there that we use in our everyday life. Now, as I've already given you an example, smartphone is probably the most ideal example of engineering. A thing that was only, a little thing that was only used to make phone calls now can do so much more. And so you schedule your appointments and meetings, or, even accessing the internet and going on social media through Wi-Fi, or even playing your favorite game like Pokemon Go on a mobile phone. And that's all being done by a group of engineers, whether it be telecommunications engineer, electronics engineer, software engineering, or any other types of engineers that came together in a team to then develop what was called a mobile phone into a smartphone, and have been developing ever since to give us, that kind of applications that we can use in our everyday lives and make our lives easier. Other examples, when you turn the light on in your house, that in itself is also engineering. Things that we don't think about, there's just a lot of engineering applications around us. And so this, hopefully by the end of this session, you will also be able to appreciate the different types of engineering that are all around us. Now let us take a look at the example of a traffic light control system. So as you can see on the screen, this is a traffic light control system. So it's like on a 4-way road. Now this is also an example of an engineering application. Engineers have to, so if you look at this 4-way road, and I'm going to move away from the animated picture and give you a bit of understanding of how engineers work out how to implement traffic light control system on a 4-way road, for instance. So see, this is kind of like a dummy road. This is like showing a 4-way road, Macquarie, Pymble, Ryde, Waste. So what engineers have to do, first things first, is to develop and understand what the major flow is. So as you can see, there's flows coming from all way. It's a 4-way road. So this is called flow 1, as you can see. So flow 1 here is the major flow. The flow from Ryde to Pymble and Pymble to Ryde is the major flow in this case. And so engineers have to determine what the major and a minor flow is, depending on how busy each flow is, or how busy each road gets. So as you can imagine, the busier road will be the major flow, and the less busy road would be the minor flow. So there are sensors at the, on the edge of each different roads that sense whether there is a car waiting or not. So in any case, if there are no cars waiting on the minor road, as you can imagine, the traffic lights will always be set to green for the major flow, and the major flow cars will just be passing through. And as soon as there's a car that is waiting and that is being sensed by the sensor on the minor road, it will give a prompt to actually finish the timing. I'll go into a little bit more details into that. Finish the timing of the major flow, and so that the minor flow can go through. So now this all looks very easy. So it's done through one flow, and you're thinking, oh, this is really easy. I could do that in my sleep, but not really. So this simple 4-way road is actually divided into 6 flows. So flows 1 to 5. And now if you take a closer look and try to see some of the flows, you probably have identified some of the flows already. Whether you're waiting at a pedestrian crossing or you're driving yourself, you will have seen these flows. They're different flows, and these flows are all timed. So they have a sequence that they are following. Like I said, the major flow usually has the most amount of time it's on for, and the rest of the flows follow after. And so this whole algorithm is all set by engineers, and it's optimized so there are no head-on collisions unless you're driving through, yellow and red, which is illegal. And so engineers also have to put into this complex algorithm the pedestrian crossings. So when you are waiting, and that little button you press, and you press a lot sometimes, you'll be like, oh, let me go already. Anyway, so that is basically a sensor letting the traffic light system know that a person, you are waiting to cross the road. And that is then taken into the whole calculation, and they work, it does a really quick calculation to work out when to let you go. So for you, on the next couple of slides, I've got a little, hopefully, fun exercise for you. So on the next couple of slides, you will see some forms of engineering. So I've included some pictures there for you as well, so that it gets you to, start thinking about what the applications could be. And so for each slide, and there will be different types of engineering. So I'll give you about 10 to 15 seconds to look at that slide and think about the applications of that engineering. And then at the end of that 15-20 second period, we'll get some of you to answer and share with you what you thought some of the applications were. So the first type of engineering which I did was electronics engineering. So there's a little picture for you. I'm not going to tell you what it is and what the applications are, but I want you all to think about what the applications are. So let's take about 10 to 15 seconds and just think about what do electronics engineers do? And can you, when you think about a smartphone, can you think of how an electronics engineer might have contributed, in an application of a smartphone? So in front of you, you can already see a picture of chips and things and a soldering iron. However, that's not the only application. Think about some of the other applications that might be used. that's an application. That definitely is what electronics engineers do. However, the application of it would be, think of a smartphone, think about the battery, think about the circuitry within the smartphone, and that is what electronics engineers would have done to present to you a better battery life and things like that. So that's kind of an application for electronics engineering. So that's definitely right. Can you think about other things like maybe electricity or, like I said, turning the lights on at your home and that kind of stuff? All these kinds of things are also electronics and electrical engineering as well. So touchscreen, it's called capacitive resistance. So when you used to use your old smartphone, you used to actually type on the keyboard. There's a little QWERTY keyboard or some different kinds of keyboard that you used to have in like really old mobile phones, and now touchscreens are used. That's right. So touchscreen, that's a really good example. So when you touch the screen with your thumb and you're typing something, there's actually electricity going through. So when you touch, there's resistance from your fingertip that causes to complete the circuit in the smartphone and actually performs what you're doing. So yeah, that's a perfect example as well. That's a really good example. Definitely. So electronics engineers would be involved in that as well. There are engineers like wireless engineers and telecommunications engineers that would also be involved in that team. So wireless and telecommunication engineers wouldn't be able to do it without an electronics engineer. So you're definitely right. Putting the receiver in so that you're receiving, communication from the outside world, basically. So yeah, that again is a very good example. So let's move on to the next type of engineering. So software engineering. As you can see, there's a couple of people on the computer trying to point out at different lines of code. What do you think? This is a really simple one. I mean, a lot of you might already be involved in coding and that kind of stuff. What do you think is an application of software engineering? That is perfect example. So like I said, Pokemon Go would be a perfect example of software engineering. So a team of software engineers would have come together to write what seems like never-ending code so that you can do what you want to do and enjoy. So not just a game, but also other different kinds of apps. So like listening to music using Spotify or something like that would also be an example of a software engineer developing that app so that everyone can enjoy different things in life with ease on their smartphone. That's definitely right. So not just on your smartphone, but a video game, if you are playing on a console, so if you're doing, playing on your Xbox 360 or PS4 or whatever, I don't even know whether it's PS5, like what's the recent one, PS4, PS5, anyways. So even games like that would have been designed by software engineers, not just software engineers, but it's a teamwork by software engineers, but also game developers who would come together to lay out the interface of what you'd be seeing, but also writing the different types of codes behind it. So when you press, write, your character moves right and that kind of stuff, and that's done through coding, obviously. And so the next type of engineering, mechatronics engineering. Now you can see a boy and a girl working on a robot. What do you think are applications of mechatronics engineering? Yeah, definitely. So if you're thinking about, as you mentioned, space exploration, and when you're designing the robots to survive in conditions that humans can't survive in as of yet, and you send a robot to see what the surrounding is like, that's an example of mechatronics engineering. So it's kind of like a mixture between electronics and mechanical, but it's also got a huge part of robotics. Other examples could be, automation, production in different factories. So even if like in a chocolate factory or whatever, automation and in the entire system, so robots are actually producing the chocolates, putting the caramel and the chocolate on top and that kind of stuff. So that is another example as well. That's a really good example, very well thought, Aladella. Yeah, perfect example. So as Aladella's mentioned about deep sea or deep or space exploration, yes, replacing human beings in a job, in a very, a dangerous job like bomb detonation. I actually did in my third year, I actually did a project where I proposed that unmanned air vehicle, like a UAV, or what you might know as drones, a drone will actually be sent to the site where a bomb's been detected, and the drone will detect the bomb and will have a surgical arm to then diffuse the bomb as well on spot. So yeah, that is a very good example of mechatronics engineering. So as you can see, the engineering applications are quite broad. They're not just one type of things, and engineers usually collaborate in a big team and usually work with lots of different people, whether it be marketing or even finance, commerce people, or IT developers, web developers, to work in a team to produce what they're trying to produce. So next type, civil engineering. Does anyone sort of have an example of what civil engineering, you can kind of see in the picture and what they're wearing, hard hats and stuff. Can you think of any examples of civil engineering? It's a very common one, and you probably pass an application of civil, or see an application of civil engineering every day on the road. There you go. So they're all examples of civil engineers. So civil engineers work together again in a team to produce bridges, or even the new metro roads that are being produced, as in being made, the new train lines that are being made. So say civil engineers will be working with Transport New South Wales to produce, to make those kinds of either bridges or train lines and that kind of stuff. So civil engineers also have lots of different applications that we use on a regular basis. So the road that you travel on, the bridge that you take, or if you're taking a metro road, that's all examples of civil engineers. So that seemed like a very popular one, and everyone kind of knew what civil engineering was. That's great. So the next one is environmental engineering, a really important type of engineering in today's world. What do you think are examples of applications of environmental engineering? That's right. So sustainable energy resources, environmental engineers, again, we will be working with other people in their team to find out new renewable and sustainable energy resources. So whether it be wind turbine energy generation, or even, I don't know if you've heard of this really cool thing that I was watching online the other day, where people can generate electricity by just stepping on this energy pad. So that again would be forms of environmental engineering, not just renewable sources, but also thinking about how we can have how can we more sustainably use the energy resources we have. So if you are making a new building, a civil engineer and environmental engineering would be working together to work out what sort of material they should be using on the building so that it's sustainable and it's environmental friendly and that kind of stuff. So whether they'd be putting solar panels, as tiles. I've seen, I'll talk about this a little bit more, but recently I visited China, and I saw there was a building, totally made of solar panel tiles, which is amazing. And so environmental engineers, like I said, would be working with other types of engineering, like civil engineers, to think of ways that they could produce, not just produce, but also use energy resources more sustainably. So that comes to the end of the kind of types of engineering that I kind of wanted you to think about, and I'll just move on to sharing a little bit of my own personal story. So when completing my engineering degrees, I had the opportunity to take part in a lot of different things. I've held a lot of different roles in the university that has helped me develop my interpersonal and employability skills. So what I want to share with you is when I was nominated to attend an engineering delegation in China, representing Australia, where I was joined by the brightest of scholars. So there were people from pretty much all over the world. And now I can truly say I have friends from different continents except Antarctica, unless penguins were invited to attend the delegation, which I'd be happy to, but they weren't. So as you can see, there's a couple of pictures of the whole group together. So there's 39 of us, and as you can see of the diversity of people, there are people from all around the world. So there are people from the United States, South Africa, parts of Africa, South America. So as you can see, there's a huge whole heaps of people that were, the brightest of scholars in the world came to this engineering delegation. And that's the group in the Great Wall of China in Beijing. And so as part of my stay there, I got to do lots of different activities. So I was able to immerse in a totally new culture in China whilst visiting some of the biggest engineering feats in the world. So I was able to go to the largest hydroelectric plant in the world, which is in Yichang, China. I went to the Volkswagen production plant. Now, I was obviously not allowed to take pictures inside the production plant, so I've got little pictures here that I took in Shanghai. And then and this is a picture from when I went to visit the Pratt & Whitney Jet Engine Center. So this company basically produces jet engines for, the Boeing 777 or other types of airplanes that you fly on a regular, use to fly on a regular basis. So now you may all think that engineering is only for nerds and geeks and that it is quite boring, but you're obviously mistaken. I hope at the end of this talk you will realize that engineering is a lot more than what you think about. And the other day I was just reading somewhere on Business Insider that engineers are actually the best business leaders and are the future leaders. So I'll directly read this quote from there. So it says that they are detail-oriented and analytical. While they are meticulous, they still take risks, but calculated ones. They identify the root cause of a problem and provide an economical solution. They tend to have a very realistic outlook on situations and don't add the fluff. They keep it simple. Finally, engineers are tech savvy and understand how it all works. This provides them with a competitive advantage over other industry professionals. They lead by example, and this ultimately helps them succeed. And so as you can see from this quote, engineering is a field that equips you to do a lot more than what you might have already thought about. Now, speaking of leadership, I've actually personally been able to involve myself in a lot of leadership activities around the campus. So I'm the founder of the Women in Science and Engineering group. So I've got a few pictures of, so this is from a time when our society, Women in Science and Engineering group, won the Equity and Diversity Award from the university for our contribution to our lives on the university campus. And so, like I said, throughout my experience, you've seen different kinds of things I've been involved in whilst I was studying engineering. So it kind of gets you to start thinking about what you could be doing with an engineering degree. Now, I've also been named as the top 100 future leaders of Australia by Grad Connection, and I've been recognized for my efforts at the university, both academically and professionally. So this is this is a picture that I took of the certificate that I received. It was a prize for EMC Best Female Engineer, and so all these different things has helped me to become who I am now. As part of my degree, I was also involved in a summer internship at a company called Schneider Electric. So Schneider Electric is a global specialist in energy management solutions, and they operate in 100 different countries. So as part of my summer internship, I was able to be involved in a team that produces custom products. So things like distribution boards in factories, schools, or hospitals. So what are distribution boards? So distribution boards are basically units that take the main supply of electricity and then distribute it to different parts of the facility. So in a hospital, the distribution board the main supply comes through and it will be distributing electricity to parts like different medical equipments, the X-ray room, and that kind of stuff. So that was, what a distribution board is. And then I was basically put in charge of a new online offering that they had, which was a metal distribution board, where I got to put different hats. So I put my marketing hat on, even though I didn't do any marketing, to raise awareness about the product amongst the customers and how to use the product, how to order the product, and also to report to the leadership team continuously about how well the new product is going. So as part of my internship, my employer, my manager basically liked me so much that they kept me on part-time whilst I was studying, and they've offered me a graduate role, which is basically a full-time role with them even before I've graduated. So that kind of gives you an idea of the different opportunities that you may have, and gives you an idea of how engineering prepares you to go into the real world. And so with that, I would like to conclude my talk here today. I'd like to thank Widening Participation once again for arranging this opportunity, and thank all of you for coming along today and to hear me speak and giving up your precious time. And now we have a couple of minutes if you would like to ask a few questions. Honestly speaking, I was more interested. I guess when I was really young, I didn't quite understand the difference or didn't quite know what I liked, but I definitely enjoyed doing maths. Every time I had to study, pretty much had to study any theory, I would just, it would really bore me. So moving on, when I started doing geography and history, I found that I wasn't quite interested in sort of learning the theory behind things, and I was more interested in doing practical things. And so that kind of led me to engineering. So when I was making my choice of what I wanted to do, when I spoke to my careers advisor and they explained to me what engineering was basically looking at a problem and then aiming to solve the problem with the existing technology rather than trying to find what is the root cause of engineers. Obviously, that also is a very important role. Scientists also play a very important role in determining what is the root cause of the problem, but engineers work sort of in the forefront in the application of solving that problem. So that to me felt a bit close to what I wanted to do. And like I said, growing up, I did have a bit of, I definitely leaned a bit more towards the maths type of things because I could just do it while listening to music and that kind of stuff. I obviously did electronics engineering, but when I wanted to come to university, I looked at environmental engineering. Environmental engineering is a type of engineering that plays a very important role in our modern day society because of the climate change issue that is facing all of us and that needs to be addressed. However, Macquarie didn't offer environmental engineering at that time, so I thought I'd do electronics engineering pairing up with a science degree in environmental science, and that would help me get to where I wanted to go. And then moving on into my degree, I decided to just stick to engineering, and in the future, hopefully I'll be able to hopefully get into a bit more environmental engineering side of things. The company that I currently work for, Schneider Electric, is very passionate about finding renewable energy sources and always looking for energy management and energy efficiency solutions. I feel like I'm in the right kind of place to broaden my horizon, not just stick to electronics engineering, but also go past and take what I've learned. So with engineering, what you will realize once you are at my stage and you've graduated or about to graduate, you'll realize that engineering teaches you in university, you can only learn so much, but then there are so many different applications in the world, and in order to get to those, and there are problems that you don't even think about right now. There are problems in the world that we haven't thought about. There is technology in the world that you haven't thought about. So engineering equips you with that kind of skill set, but it is that whole problem-solving, analytical mindset that is drilled down in an engineer that helps students and helps professionals to develop their skills and get on-job training to then branch out. So if I were to say favorite type of engineering, I guess for you guys, mechatronics might be really cool, so you're doing lots of robotics. I, however, don't have a favorite type of engineering, but have all types of favorite type of engineering. Say if you hate maths, then engineering might not be the best thing for you, because in university you'll actually be doing lots of maths, and it's not the calculus algebra that you do, but it's engineering maths. So it takes the basics off from the maths and then leads you to do more. So in terms of subject selections, I'd be looking at doing maths, obviously, probably extension 2 or higher if you can. Even look at doing physics. Chemistry, you can if you are interested in becoming a chemical engineer or other types of engineering. However, chemistry isn't absolutely necessary, but for me, I would think physics and maths would be, absolute necessity if you wanted to go into engineering. If you want to become a software engineer, for example, you could think about doing coding type subjects if your school offers that kind of subject. Actually haven't done HSC, so I did the British curriculum, and I did maths. I did advanced maths, and so advanced maths is like extension 4 here, so it's quite high level of maths. And I did chemistry, I did physics, and I also did accounting, which was, it was mathsy, so that was good for me. It helped me think in a whole different type of way. So these are kind of the subjects that I chosen. It's a slightly different curriculum and different type of subject selections. You probably have to choose more subjects, but these were kind of what I selected when I did what is equivalent to my HSC. I actually never really thought about it before starting university, but when I started university in my first year maths class, I was like, oh my god, I really love maths, should I think about doing mathematics? But then as I progressed further on my maths class, I was like, nah, mathematics isn't my thing, because when you are doing maths as a subject, you look at a lot behind the theory as well of how this formula was derived and what are its applications. For me, I loved maths, but I guess I didn't love it enough to go into maths. So I'm a very results-oriented person. I like to see results. So for a mathematician, they might spend years trying to prove a formula or trying to get behind someone's theory, but never have a result, whereas I want to see results immediately. So for me, engineering felt like, okay, so there is maths component. I love maths. I take the maths and I utilize it in a form of an application to see actual results. Really depends on what type of engineering you're going into. So like I said, I've just worked with a company called Schneider Electric for my engineering experience. I haven't had a lot of exposure to the different types of applications in the real world. Personally, I haven't, but obviously know of. So there's not just one type of thing that engineers do. So they could be project engineers that working on, like projects with New South Wales Transport, in new train lines or metro roads, that kind of stuff. Or where I work, we always constantly looking at energy management and energy efficiency solutions, and thinking of renewable energy resources. So we're always trying to optimize the use of energy. So how can we more efficiently use? So there's this, obviously energy is, we don't have it in abundance. So we have to think about how can we use this little we have to sustain us from now to years to come. So I guess there's so many different applications. Engineers also move on to different things like consulting, for instance. So consultants where they use their their technical background to speak to customers, to understand what their requirements are. So say even working like, thinking like, I've known engineers to move fields completely and to work in consulting where they look, where they say have clients that want, so big companies come to you to say, so this is our process, how do we optimize production, how do we optimize our employer turnover rates, that kind of stuff. So I know engineers who've also gone into that kind of field, who use their technical knowledge but not so much the engineering maths, so they don't do that engineering maths on a regular basis, but they are using that technical knowledge because it is required to understand those terms, to then speak to clients and solve their problems. So engineers are not only, not only, I guess the job prospects for engineering is not just limited to technical jobs, but also to do jobs that, like I said, like consulting, where you use your knowledge to then implement and apply your problem solving, your analytical skills that are really important, to then do something completely different. I know engineers that have gone to data analytics that look at big data. So say when you swipe your Woolworths card, rewards card, and so so Woolworths basically picks up on the data that, oh, this person here has bought toilet paper rolls and something else, and so they kind of receive a trend because, oh, okay, so on these particular days there's a particular demand for toilet paper rolls, so on this day we should have a special. So engineers have also moved on to that kind of roles like data analytics, so that they can help the industry optimize production, sales, and that kind of stuff. So it's just very broad. Engineering's a type of degree that does not limit you. I've seen job applications. Engineers can apply to anything, pretty much. Anything and everything. They can apply to any job. People have wrong perceptions that engineering is only for male students. So it is true that there are more male figures in engineering than female students, or even like coming and doing engineering in university. However, I personally would like to think I have seen some change. I've seen heaps of girls starting engineering at university. So one of my job is a student ambassador, where I go out to schools and do presentations and careers market. So I've seen an increase trend where a lot of female and male students are coming up to talk about engineering, so that's always a positive. Look, the numbers for the female in engineering are quite low. However, there is a national push from the government to increase the gender diversity and increase the number of women in engineering, because big companies and employers have understood or have realized that it is important to have as many female engineers as male engineers in their workforce, because it creates a more diverse and healthier workforce, and it represents the client or the customer base more evenly. I mean, obviously it's a 50-50 population in the world, and so if there are only male engineers, they're only going to think about their type of thing, what type of application they would like to think. So if there are more female engineers involved as well, and that represents a more a diverse sort of workforce, and also that represents a diverse customer or client base, which allows them to be more productive and show better results. So going back to what you asked, I've started seeing a few more female students asking more about engineering, and I hope after this talk a lot more will be asking about engineering. So the change is starting. The government has taken this into note, and this is something that there's a national push for it, and so we're hoping that possibly in about 10 years time we will see approximately hopefully 40-60, if not anything, in terms of proportion of female to male engineers. Thank you very much for having me. It was a pleasure.